Imagine this scene. It's the turn of the 20th century. You've got these brilliant scientists, Michelson, Newcomb, Kelvin, even Philip von Jolly, Max Planck's teacher, and they're basically saying, yep, physics is pretty much wrapped up.
Right, the important fundamental laws are all discovered. Newcomb even thought astronomy was hitting its limits.
And then bam, almost right away, we get quantum mechanics, relativity, the universe expanding. It totally turns everything on its head.
It really does.
Makes you think, doesn't it? If they could be so sure and so wrong, what huge ideas might we be missing right now?
It's a powerful question, and it kind of sets the stage for what we're diving into today, inspired by Neil deGrasse Tyson's book, Death by Black Hole. He basically says, look, we're maybe not as smart as we think.
Yeah, dumber than we normally admit to ourselves.
Exactly. Meaning we've really only just begun to figure out the universe. So our goal today isn't just listing facts. It's about getting some real insight, seeing the universe as this grand play with complex plots.
And speaking of new insights, that's what we really aim for on our YouTube channel, Mindful Moments. It offers these AI-powered book analyses, a bit like this chat, designed to spark some reflection, some rational thought, all in just a few minutes.
A great way to get those mental gears turning.
Definitely. Now, let's unpack something fundamental. Our own senses, our basic five senses. It's kind of startling when you realize hardly any big scientific discoveries in the last 100 years came directly from them.
It's true. Imagine, like Tyson suggests, a weird glowing blob just appears. Your eyes, ears, nose, touch. They tell you almost nothing useful.
You'd be totally clueless about what it's made of, any fields it has, radiation, nothing.
Precisely. And that's where science steps in with, as Tyson puts it, sense-transcendent mathematics and hardware.
Yeah.
It basically turns us into super-sentient beings, in a way.
Super-sentient beings. I like that.
Yeah, think about it. If you could detect magnetic fields directly, compasses are useless. You'd just see Earth's field lines.
Or spectrum analyzers built into your eyes. You'd instantly know the air's composition, or that, stars are made of the same stuff as Earth.
Or spotting radioactivity from afar without a Geiger counter. Just knowing. These tech-enhanced senses open up this incredible majesty and complexity we just couldn't perceive biologically.
So what was that pivotal moment, that scientific leap that let us grasp the whole electromagnetic spectrum as one thing?
Well, a lot of credit goes to Heinrich Hertz back in the late 1800s. He showed experimentally that radio waves, light, infrared, X-rays, they weren't separate things.
They were all related, cousins, basically.
Exactly. All electromagnetic radiation, just different wavelengths, different energies. That unification was huge. It really unlocked the invisible universe.
And what kind of things did we suddenly start to see with these new non-biological senses?
Oh, amazing things. Take radio waves. Carl Jansky in the 30s wasn't just getting static. He pinpointed radio signals coming from the Milky Way center.
The galactic center itself.
Yeah. So strong that if our eyes saw radio waves, it'd be one of the brightest things up there. Radio basically gave us cosmic hearing, you could say.
Cosmic hearing.
And infrared. We see it in heat lamps, right? But if we saw infrared naturally, we'd spot heat leaks in houses, see warm objects in pitch darkness. These extra senses fundamentally shifted our common sense about reality.
Making things like black holes and the Big Bang eventually seem, less completely bizarre.
Exactly. They started to make sense because we had the tools to detect the evidence, to see the universe in these new ways.
Okay, from expanding our senses, let's take a trip, a really, really long trip.
Yeah.
Into the sun's core with a single photon.
Right, this heroic adventure. Imagine a photon born deep inside the sun. It doesn't just fly straight out.
No, it takes this random walk bouncing off atoms constantly.
Constantly, for about 1 million years. It takes nearly 5 sextillion steps to get to the surface.
1 million years for light to travel what should take seconds.
Just 2.3 seconds if the path was clear. It shows the sheer density and the chaotic energy down there. And think about it, only 1 photon in 500 million actually hits Earth.
That's Earth's rightful share. It seems so inefficient, but I guess it works.
It highlights the incredible scale, the immense power needed just to give us that tiny fraction that sustains life here. Cosmic generosity, maybe?
And this journey inside the sun points to a bigger story, right? The Big Bang gave us hydrogen, helium, a bit of lithium. Where did everything else, the stuff we're made of, come from?
That's the stars. They are the universe's element factories. As Tyson says, stars forged all the rest of the 92 naturally occurring elements.
How does that work? inside the star.
Well, in cores hotter than 10 million degrees, hydrogen fuses to helium. Bigger, hotter stars keep going, fusing heavier elements, carbon, oxygen, all the way up to iron.
But iron is kind of the end of the line for fusion energy, isn't it?
It is. Fusing iron actually costs energy. So when a massive star builds up an iron core, it's a bad day for the star. The core collapses incredibly fast.
And that triggers the big one.
The monstrous explosion. A supernova.
And that explosion isn't just destruction, it's creation too, right? The supernova's greatest gift.
Absolutely. It blasts all those newly forged elements, oxygen, carbon, nitrogen, all the main ingredients of life as we know it, out into space, seeding the interstellar gas clouds.
So the stuff of life comes from dying stars.
Precisely. Tyson nails it. Not only humans, but also every other organism would not exist but for the wreckage of spent stars. We are, quite literally, stardust.
Noble detritus, he calls it. We should celebrate it.
Yeah, what nobler thought can one cherish than that the universe lives within us all? And those enriched clouds cool down, atoms stick together, form molecules, especially carbon-based ones.
Becoming happening places for more chemistry.
Exactly, leading to new stars, new planets, and, well, maybe new life.
Okay, that leads us perfectly into redefining living space. We used to think of the habitable zone or Goldilocks zone very narrowly, didn't we?
Very narrowly. Basically, the zone around a star where a planet's surface could have liquid water. It assumed starlight was essential.
But then we looked at Jupiter's moons, like Io and Europa.
And the whole picture changed. We found they're heated by other energy sources. Io is a volcanic mess because Jupiter's gravity squeezes it.
Most volcanically active place in the solar system.
Right. And Europa almost surely has a deep billion-year-old ocean of liquid water beneath its icy crust.
Heated not by the sun, but by Jupiter's tides. Internal heating.
Exactly. Geothermal heat, essentially driven by tidal forces, and these internal heat sources can last for billions of years.
Which leads to a pretty wild idea.
Could interstellar space be teeming with life? Maybe on rogue planets, ones kicked out of their solar systems long ago, but still warm inside.
So the habitable zone isn't just a belt around a star.
But it seems the habitable zone is indeed everywhere. Wherever you have liquid water and energy, life might be possible.
That's a radical shift. It vastly expands where we might look for life. And what about the ingredients for life? Does the chemistry line up?
It lines up incredibly well. Look at us. Hydrogen, oxygen, carbon, they make up over 95% of our bodies.
Those are
among the most abundant chemically active elements in the whole universe. Helium is more abundant, but it's inert. Doesn't really react.
So life on Earth isn't using weird, rare elements.
Not at all.
Yeah.
It suggests life on Earth is not immune to the Copernican principle.
Mm-hmm.
We're likely made of the common stuff because it is common. Alien life probably is too. Not based on, molybdenum, bismuth, and plutonium.
Though maybe not always water-based. Could other liquids work?
Possibly. Ammonia, ethanol, methane. They can be liquid under different conditions. It broadens the possibilities even further. Life might be chemically similar, but adaptable to different environments.
It's just amazing how science keeps moving, discovering things, but also getting stumped. It's this constant dance.
It really is. Yeah, you mentioned Simon Newcomb earlier, thinking astronomy was done. And then think about Percival Lowell.
Oh, the canals on Venus, which turned out to be.
The shadows of blood vessels in his own eyes, reflected back from the telescope eyepiece.
Wow. Talk about a humbling correction. That's incredible. It shows how easily we can fool ourselves.
Exactly. Or even the whole debate about Pluto's status. Is it a planet? A dwarf planet? It shows knowledge is constantly being refined, reevaluated. Bafflement drives discovery, as Tyson says.
Richard Feynman had that great analogy about physics, didn't he?
Yeah, like watching a chess game without knowing the rules beforehand. You only get glimpses, peeking at the game in progress every now and then, trying to figure out the rules.
And the universe's rules are way more complicated than chess.
Infinitely more complex, it seems,
Mm-hmm.
which is why astrophysicists are constantly baffled. Think about Hubble discovering the universe is expanding, or Fritz Zwicky finding evidence for dark matter back in the 30s, stuff that makes up 90% of gravity in the universe, and we still don't know what it is.
Still a huge mystery. And unifying gravity with quantum mechanics.
Quantum gravity. The Holy Grail, still out of reach. But even with the bafflement, human ingenuity just keeps pushing.
Like building massive particle accelerators, CERN, for example.
Right, recreating conditions near the Big Bang. Even creating tiny amounts of antimatter, like anti-hydrogen.
Yeah.
We're actively probing the fundamental nature of reality.
And we're looking outwards, too, thinking about space colonization. You mentioned Lagrangian points.
Yeah, L4 and L5. These are stable points in orbit where gravitational forces balance out.
Like parking spots in space.
Perfect parking spots. Ideal for building huge, rotating space stations, maybe eventually cities in space, where spin creates artificial gravity. It shows we're not just discovering rules, we're figuring out how to use them.
And all this rests on incredibly careful measurements built up over centuries. People like Cavendish measuring gravity, Galileo, Romer Bradley measuring light speed.
Precision is key. And it's funny how that history is baked into the language of science itself.
The units we use.
Exactly. Watt, Faraday, Hertz, volta, ampere, joule, named after the pioneers who helped us understand and quantify energy and electromagnetism. Their discoveries are literally the units we measure the universe with.
So as we kind of wrap things up here, it feels like the big takeaway is that this journey of discovery is far from over. Expanding our senses, peering into stars, rethinking life's possibilities. It just keeps revealing a more complex, more surprising universe.
Absolutely. Science isn't about having all the answers. It's this ongoing process of questioning, learning, and, importantly, updating our common sense as we learn more. It's about the insight, not just the facts.
And if you want more insights like these, definitely check out our YouTube channel, Mindful Moments. We delve into books and ideas to get you thinking. And, of course, you can find our podcasts wherever you usually listen.
Keep exploring those ideas.
Yeah, definitely. If you enjoyed this exploration of the cosmos, please do subscribe to our feed, maybe share it with a friend who appreciates those aha moments. You can also grab Neil deGrasse Tyson's excellent book, Death by Black Hole, using the link in our show notes.
It's a great read.
It really is. And most importantly, just keep thinking critically. Keep questioning the world around you. Keep learning.
Because the universe's story is still being written, right? There's always another layer of wonder.
Yeah.
And maybe the most fascinating stories are the ones still waiting to be found, including the ones hidden deep within ourselves.